Hi all, my name is Tushar and welcome to my YouTube channel. In this video, we are going to understand what is machine learning model training. We will understand the theoretical part of it, and in the later part of the video, we are going to train a regression model, a machine learning regression model from scratch in Python. So please stay till the end. It will help you to better understand what is model training and understand every aspect of it. All right, so let's get started. Let's say we have a problem in which we have some data in which we have two fields. So one is this is a land data, let's say. One is the area of the land, another one is price of land. These two fields we are having in our data. Let's say this is the data we are having. Let's try to plot it on the graph. Let's plot the area of the land on x-axis and price of the land on y-axis. What does our basic common sense tells us? Our basic common sense tells us that as the land area of the land increases, the price of that land will also increase, right? Let's say area of the land was this much, the price of the land was this much. Area increases, the price also increases. If area again increases, the price again increases, right? So it seems to be going like this, let's say, from our data points. Let's say we had just these three data points, x1, x2, x3, y1, y2 and y3 is the corresponding price. Let's say data is something like that. All right. Now let's say a vendor comes up with the area of land. Let's say someone comes up that he says that my land area is nothing out of x1, x2, x3, but it is x4. Let's say something x4 here. What should be the price of my land? Right, this is a predictive analysis problem. Like he has to predict what should be the price of my land. So what he will do, he will just draw this graph kind of thing, and where it intersect the line, it will mark it as the price of its land. Easy problem, right? In this case it seems to be easy because it is a perfect line, right? But what if it's not a perfect line? In reality, we do not get such a data, right? We do not get such a smooth, perfect line. What if the data is something messy? What if I tell you how the actual data would look like if you try to look. You see, the actual data will look something like, let me draw the graph. The actual data would look something like this. Right? This is not a perfect line. And still, if the person wants to do the predictive analysis, let's say a person comes up and he has area of the land with this much of value, what should be the price of that land? This is a real problem in the real world. We daily deal with such kind of problems. So what does our common sense tells us? Our common sense will tell us that okay, we do not have a perfect linear data, but we can assume it to be a perfect linear data because it looks like that it is following a line, right? If we make a line through it, it seems to be following that, right? It seems to be along this particular line. So what we will do, we will make a line which is going through this data. If this is the something we have to predict. Like what should be the slope, what should be the intercept of this line, like whether it should be, whether this line is good, or this line is good, or this line is good, which one we should go with, right? And once we have a uh, good line, once we know, okay, we should go with this particular line, we will just uh, draw the graph, and we will pass this value of x, and we will find the price of the land which should be marked for this particular area, right? That way it is an easy problem. But now the problem boils down to a single analysis, that which one should be the perfect line, whether it should be this one, whether it should be this one, or whether it should be this one, or whether it should be this one. There are infinite many choices, right? There are infinite many choices of slope and the intercept of this line, right? So how to predict which one is the best line? So machine learning model, that's why the machine learning model comes into the picture. That's where we train the machine learning model on the data which we are having, and then machine learning model will tell us, okay, this is the price of the land, and this should be the, this is the area of the land, and this should be the price for this particular area. All right, now let's try to understand how to train a machine learning model on such a data. Now if you have gone through my previous video, I explained a very important thing, which is gradient descent, because gradient descent is the heart of machine learning, and you really need to understand the gradient descent before understanding how to train a machine learning model. So if you do not know what is gradient descent, I will request you to please go and watch that video and then come again. And if you already know what is gradient descent, then please stay here, like I'll make you understand what is machine learning training model. All right, so what happens in a machine learning model, like let's say, let's try to understand it from the perspective of this line only. When we talk about a line, let's say this is the line, linear line, let's say, this is y, this is y, and this is x, right? Like the normal equation of the line is y is equals to mx plus c, right? M is slope of the line, and C is the intercept. This is what the line is composed of. One is slope, and one is slope, which tells us the angle of the line along with the x-axis, and C is this point which intersect the line along with the y-axis. Basically, line, a 2D line is composed of these two things only, a slope and the intercept. And when you change the slope, let's say you reduce the slope, and then line will become something like this. If you keep on reducing the slope, if you keep on changing the c, the line will move along the y-axis. So line is composed of just m and c. I'm talking about line because to the reference of our problem which we just discussed, the area of the land and the price of the land. This is, you can assume the area, this you can assume to be the price, and we have to find the line which is the best one out of these three, like, right? We have to basically predict the slope and the intercept of the best line, which seems to be this one in this case, right? This one, or can be anything else, right? Can be anything else as well. So our whole problem, like if we try to map the things to just in the reference of this problem only, the area of the land and the price of the land, the whole problem boils down just to find the slope and the intercept of the line which makes the best fit through our data. Now what does this best fit means? What does this best fit means is, let's say our data is this one. We have just 3 points, let's say, right? This is the data, and we have to fit the line through these data points. We come up with the assumption, let's say this one. Let's say this is the line which we fits through these data points, and the equation of this line is, let's say, y is equals to mx plus c. M and c are constant, actually, slope and intercept. How do we know that this is the best fit line? Like, we will try to find the error along with the data points, existing data points. This is what a machine learning model also do. Like, it tries to random assume a random line which goes through the data, and then it try to compute these errors which we are getting from the existing data points. Let's say this is E1, this is E2, this is E3. The final error, the summation of these error, let's say capital E, is summation of E1 plus E2. Sorry, it is the summation of EI. Let's say, let's remove this next term, I, from 1 to n number of data points. This is a complete error, and let's take the average of it. This is the average error, let's say. Now, if this line is a perfect fit, or let's say when we will say that this line is the best one, when for this line this error should be minimum, right? It makes sense, right? If this error is large in the existing data points, then we are not having the great line, best fit line. The best line will be the line for which this error is minimum, right? This complete error should be minimum. And in the world of machine learning, we call it as loss function, loss, which we are getting from our model. So what our model will do, we will pass the whole data to our model. Our model will come up with the initial assumption with the initial m and c. It will assume, okay, this is some random value. It will pick up from a distribution, and it will compute this error. It will compute this loss function. Then it will start tweaking m and c in such a way that this loss reduces. And how does it do that? It does with the help of the gradient descent. That's where the gradient descent comes in the picture. Let me make you understand the whole story. So what the machine learning model, how the machine learning model will be trained, like what is the pseudo algorithm that we will, let's say this is the model, we give it some value, some data points, capital X, let's say. Capital X is the, like, we are giving all X in one go, and then it will predict us capital Y corresponding to those X. Capital X is basically the vector form in which we are from data points from x1 to xi, and Y is actually the predicted values for those X's, let's say from y1 to yi. These are the predictions for these data points. Now for these data points, we have some ground truth values as well. Like, in our data, we know, like, if this is the area of the land, this must be the price. We have some ground truth values for the price. So we will compare those price value along with the predicted values. These are predictions, these are originals, ground truth. Let's say again, let's give some other symbol, capital Y, let's say y0, y1, and then it will compare these two. It will take the loss between these two. And what is the loss? Loss is basically, in the case of a regression, it is the mean square error, which is actually the summation yi predicted minus yi original square divided by n. I goes from 1 to n. So this is the loss function, which this is the basically the loss function of the model. So whole model, in the case of linear regression, Basically linear regression is something in which we have continuous predictions. Here we have area of the land, and then we have price, which is continuous in nature, right? So this kind of problem is known as a linear regression. So in the linear regression, the loss is basically this one, uh, and this is basically known as mean square error, MSE. So our model, but the model will be trained, during the model training. What will happen, like it will try to reduce, it will tweak its model parameter, which in our case will be slope and the intercept M and C. It will try to tweak them in such a way that this loss reduces. And how does it tweak them? Basically it will like we have some the whole algorithm is something like this. Like let's say M naught and C naught, these are some random initialization, and then we will tweak them. M naught will be converted to M naught minus dl by dm naught, and C naught will become C naught minus dl by dc naught at m is equals to m naught, at c is equals to c naught. So the whole story is basically, let's say we have this machine learning model here. We have this machine learning model. It will assume that there is a random initialization of slope and intercept, which is m and c naught in this case. These are actually called as the model parameter, which are getting tweaked, which are getting switched during the model training. Now we'll show this data to the model. It will come up with some random m naught and c naught. It will make some prediction. We will compare those prediction along with the ground truth. That's how we compute the loss. And we are having this loss, and then the m naught and c naught will be tweaked in the direction that this whole loss reduces. This one. And how does it reduce? It will reduce if we tweak the m naught and c naught according to this particular equation. That is the whole story. And this equation is known as gradient descent. If you do not know what is gradient descent, I have explained it really well, and we have even coded it from scratch in Python. I'll give you the link of that video in the descriptions below. But there is the whole story of the model training in linear. That's how the linear regression model is trained, and it works. Basically what happens is, if we keep on training it in such a way for several iterations, you will see that you will get a perfect line, perfect fit. It will randomly assume any m naught and c naught, and if we keep on tweaking m naught and c naught according to these equations, we will end up getting a perfect fit. You will see this in demonstration when we will code the whole algorithm from scratch in Python, just in a minute. All right, so I hope you have understood this, and let's move to the coding screens. All right, so now we are in the coding screen, and let's try to understand the code, like how to code the linear regression from scratch. So in the first cell, we are just importing things up. I have prepared this notebook for you guys, so you can go through it, and I'll be uploading this whole code on the old GitHub. And yeah, so like first of all, I have written this function. Basically what this function do, like it generates the fake data. We take a line, a xy line, a y is equals to mx plus c, and we will basically just add a random noise into the y value, so that data become a little bit randomized. I'll just show you, like it will just okay, let's say we are taking the slope as 5 and intercept as 2, and passing it to this function. This taking the true slope and true intercept, which is 5 and 2 in our case, and we are saying that okay, generate me 100 samples of this data set, and x range is from 0 to 10. Obviously x is varying from 0 to 10, and the noise standard deviation is 2. Random state we are setting as 42. So let's try to understand this function. Here we are initializing a randomizing object. Basically it will randomize things up. np.random.default range. We are passing a random state to it, and here it is drawing samples from the uniform distribution. This particular parameter will give us the mean of that normal distribution, and this will give us the standard deviation of that distribution, like how much varying it is. And in our case it is actually 10, like x will be from 0 to 10, anything it will be like the standard deviation is up to 10 and the mean is around 0. So samples can be from 0 to -10 and +10, so it is something like that. So, and we are saying that okay, generate me n samples, which is 1000 in our case, and then we are generating noise. We are keeping the mean value as 0, and standard deviation tells us okay how much that noise should vary along 0. So we are setting it 2, so it can go +2 and -2, and some random values will be coming within this range -2 to +2. In the case of x, there will be like random values coming within the range 0 to +10 and -10. X will be varying like this, and noise will be varying with much smaller standard deviation. We find the y is we apply the equation y is equals to mx plus c, and then we add a noise, so that we can basically get a data to simulate the regression. Basically I'll show you. We are just adding the random noise to y, so that it is not a proper line but something varying along with it. I'll just show you diagrammatically. So let's initialize it, and this is a function to visualize our data. What we are doing here is we are taking the y true, which is the true slope plus x into x plus c, which is equals to y is equals to mx plus c, this part basically just. And we are not like just to visualize things up, we are drawing this line and then we'll be adding noise to it. This is the true, like this is the true value of y. We are just plotting it up, and then we are plotting a scatter plot for the y true, and which is this value, basically the added noise value, which will simulate the regression data set. So let's run it up. So you see this line is actually the line along which the noise is added. This line is basically the slope is something which is this one 5, and true intercept is 2. This line represents that, and we are adding noise onto this line to simulate the regression data set. This is the regression data set along this line. So now what our expectation from our machine learning model is, we will pass this random data, these dots you see, we'll pass this data to a machine learning regression model, a linear regression model, and we will expect our model to learn the true slope value, which is 2 in our case, and the true intercept value, which is actually equal to 5. So for that, let's write this class. This class is basically tells us the regression model. Okay, this is the slope and this is the intercept. Obviously the slope and intercept is something the model will learn, but we have to initialize it with some random value. So we will initialize things up, the slope and intercept, with some random value, and our model will be, you'll see that our model will learn that the true slope should be 2 and true intercept should be 5. These are the parameters which our model should learn. We'll pass this data, this y true data, not this one true y, but the y true and the x. With this data we'll train our model, and our model will learn basically okay, this is the line along which these points are varying, you'll see. So let's initialize this class. We'll passing the slope and intercept, and we are initializing a function which is the method in the case of Python, and it should return the slope x. Okay, basically we are like telling the model, okay, this is what you should return for a particular x. Then we'll take a loss value from the original y, take a difference between them, and then the slope and the intercept will change using the gradient descent principle. So let's initialize our model. We are randomizing the slope with 8 and 1 right now. We can randomize it with any other value as well, but currently we are randomizing it with 8 and 1, and it is expected to learn that it is actually equal to 5 and 2 and not 8 and 1. Let's randomize it. So you can check the model dot slope is actually 8, and model dot intercept is actually 1. So these are the randomized value, the initial parameters of the model, and normally we will train our model on the data set, this data set, and you'll see that our model will learn these values that is actually equal to 5 and 2 true value. It will reach to true value. That is actually called learning in the machine learning. So here we are defining the loss function, which is actually, which I showed you in the theory part as well, actually equal to the y true minus y predict whole square mean of that particular thing. And you see, okay, yeah, here we are saying that, okay, what is the initial loss we are getting? So this is the initial loss, which is pretty high. We are passing the x values to the model dot predict. We are getting some y predict, and we are taking the loss between y predict and y true, how much they are dissimilar. Basically, through this loss function we are quantizing that particular parameter, and this is the value we are getting for the initial thing. Actually, you'll see during the model training this loss will actually reduce, and this should reduce, right? All right, so next thing is we should be having functions which tells us, okay, what is the derivative of slope and what is the derivative of intercept with respect to loss. So let's try to understand that a bit. So y predict is actually equal to mx plus c, or mx plus b in our case, because we are calling b as the intercept, and m is the slope, and the loss is actually this one. So if you differentiate this loss with respect to m, this will be the equation, right? And if you differentiate loss with respect to b, this will be the equation, right? So these are the functional equations which we should be returning as the gradient of loss function with respect to slope, and the gradient of loss with respect to intercept, right? So here we are coding it up. Slope gradient is actually this one, minus 2, actually this is the mean, right, divided by n, x into y true minus y predict, this is the y predict, mx plus b, and this is the gradient of the slope, right? In the same way, I have written the gradient of the intercept, which is this one, y true minus y predict, which is actually this one mx plus b minus 2 by n, right? And this is the update rule, the gradient descent rule. Like m new should be updated with m old minus learning rate into slope gradient, and same goes for the b new. Like it will be keep on updating according to this particular equation, and basically I have written that only here. Like we are passing the x to the model, we are taking some predicted value, we are computing the loss along with the y true, and basically we are taking the gradient of this loss along with the slope, which comes up from this function, the dl by dm. Basically this is slope gradient at this particular value of x and y, and this is the intercept gradient for this particular value of x and y. This go to this particular, we are keeping learning rate as 0.01. You can experiment what happens when you change the learning rate, basically. And this is how you upload the update the slope value, m slope, this particular update thing, and this particular update thing for the intercept. And I'm just printing not at every epoch but at every 10th epoch. So let's run it up. All right, so it's pretty fast. You see, initially the loss was 255 and then it was 4.2, 4.1, 4.15, 4.12. It is constantly reducing, right? And you see, initially the slope was 6, then it comes to 5, 5, 5, and it comes up, right? So slope and intercept eventually reaches up to the 5 and 1.8. And what was the true value? True value was 5 and 2. We are pretty close, right? So this is the thing which the model has learned, right? We initialized it, the model, with some random slope and random intercept, and we train the model, and eventually the model learns that okay, this should be the slope 5 and this should be the intercept 1.8. Let's check. All right, so it is this one. You can see that model has learned something, right? And all right, so this is the model learning, guys. This is something else, you can forget about that. But you see that the model has learned. These are the parameters the model has learned. You can train it for some more epochs as well if you want to reach to some other values. You see the loss is still reducing from 3.8355, but it is pretty much saturated. It is not reducing after this value, and we have reached pretty close to the actual slope and actual intercept. This is actually the machine learning, guys, and this is how you train a regression model. So I hope you liked this video. Please like and share this video if you found it informative, and if you learned something new, please leave a comment, and if you didn't understand anything, still leave a comment. I'll be happy to reply you all, and see you in the next video. Bye bye.